Hello everyone. So this is a video for a course that I'm teaching, which is MEM 1713 Artificial Intelligence Session 22-23-2. Okay, so in this video, I'll be teaching you or showing you how to use Matlab to train your machine learning models. Okay, so this will be a bit raw and unedited. So you would notice, so I'm not going to edit this. So you'll be seeing lots of pauses and mistakes, and which will be corrected, hopefully, and so on. Okay, let me see how I can adjust the font size. All right. Do you think 18 will help you? Okay. All right. So if you haven't used MATLAB before or installed it, so for UTM students, you can go to the Software Center on UTM portal and download and, I don't know, apply for a license or something, and then install, and you can start using it, right? So a brief introduction on the layout. Also on the left here, this is your folder, and you can change your directory by navigating yourself here. Okay, so you can click this icon, says browse for folder. You select your folder where you want to work in, and this will display all the folders and files in that folder. Okay, and this is the command window where you can type codes or scripts, and or should I say commands, right? And you can execute them. There's one option. Another option is to create a new script by clicking here. Then you can type the same thing here, save it, and you can run again some other time, right? So if you run it here, then you will not be able to save it. Okay, and this is your workspace. So any variable that you declare will appear here, or declare or define, right? Depending on what you're used to. And this is the command history. This part here, this panel, will display all the commands that I've used before, and you can just double click or click once, I cannot remember, to execute again. So let's see some examples first, right? So the way to declare or define your own variable is, if I say k equals to 1, you can see immediately the variable k appears here, right? So the next time you call k, so MATLAB says that k equals to 1 because you have already declared, and it appears here on the workspace. Okay, so same thing, if you have a script, then you can type it here, save it, and you can run by pressing this green play button, and it will execute whatever it's written in this file. Okay, so I will just delete this file. So I think I'll be just using the command window. Perhaps it's easier for me to explain rather than using a script. Okay, so the way to clear this command window, if you want to do it, is CLC. If you want to clear the workspace, you type clear all. Okay, so this semicolon is used to suppress the output. So if I say k equals to 1, semicolon, then the output is not displayed again, right? So if I remove it, then it will say the output is not suppressed, as we say it. And you can plot functions by using plot. If I say plot, before that, if I still remember well, if I want to generate a random variable, if I type 5, I should have like 5 by 5 random variable. If I type like this, 10 by 1, that means I have 10 by 1 random variable between 0 and 1. So I can use plot. And if I want to plot those random numbers, then a figure should be created, and by default it's a line plot. Okay. Okay. All right. Never mind. I wanted to, because I couldn't move the window around because the WebEx panel is blocking. So I'm seeing how to. Never mind. All right. What next? We are going to do machine learning. So I'm thinking what to do first. All right. All right. Let's Okay, let's talk about random samples as we will be using later. So yeah, there's a function, Matlab function called random sample. So if I say from 1 to 10, generate 7 random numbers. So it will generate 7 random numbers, 1, 2, 3, 4, 5, 6, 7, between 1 and 10, right? I'll run this again. Again, another random sequence of numbers will be generated, right? You will see why I'm doing this later, or where we will be applying this. Okay, let's create a simple data set. I have consists of maybe 11, 11, 11, 11, 11, 12, 12, 12, 12, 12. So I have this data set, which is the 5 rows. The first 5 rows are 11s, and then the remaining rows are 12s, right? So if I want to access any of these elements, of course, I can use this. I think it's this. So if I say data 1, oops, sorry. So data 1 means I'm accessing the first element, and data 10 is I'm accessing the last element, right? So if I say data get me element 1 till 5, so it give me the first 5 elements. I can even use another way, which is by using logics or logical variables. If I say true, true, false, 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 false. One, two, three, 4, 5, 6, 7, 8, 9, 10. So first of all, this is an array. Let me just run this first. This is an array, this is an array that consists of logical values or variables. And they are true, true, false, 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 right? 10 of them. So in other words, it's like 1, 1, 0, 0, 0, 0, 0. I can use this as an index to access my data set, which is data. So recall that data has these elements. So if I want to access the first two values or elements, I can say data, parenthesis, and the array consisting of the logical values, right? So it says, okay, it is 11, 11, right? So we'll be using this later when we have our actual data set and to partition our data set into training and test sets. So what's next? Okay, but when we partition our data set, we have to do it randomly, right? So 70% of your whole data set has to be randomly selected, and that will be our training data set. And the remaining, which is again random samples, will be our test set, right? Let's see how we can do that. Again, this is related to the function that I showed earlier, which is random sample, this one. Okay. So if I say, let me create a variable called idx train. Idx stands for index, and these are all false. How many false? 10, because I have 10 rows of data here, 10 by 1. So this will create 0, 0, 0, 0, 0, 10 of those. Okay. Next, if I say within this IDX train, which is all 0, 0, 0, 0, right? Select randomly 7 of those from 10, right? So again, I'm using my random sample here. So here what it says is that generate 7 random numbers between 1 and 10. Okay, so you can imagine in our IDX train, I'm selecting 7 values of this, or 7 positions, and then I will turn them to ones. So I say equal true. So you can see here from all zeros, now we have some of those are ones, right? Because I say choose these random elements, which is 7 of them, and change them to true. So I have 1, 2, 3, 4, 5, 6, 7 of those is 1, and remaining, which is 3 or 30%, are still zeros. So now, if I want to access 70% of my data set, which is data, right? I say data, 70% of this, what do? I say data. I can simply use IDX train. Okay, so there you go. So 1, 2, 3, 4, 5, 6, 7. Right? And if I want to access the remaining 30%, I would say maybe I can create another index or vector of index. I call it IDX test, where this is IDX train equals false. Okay, so this will say that whenever it's 0, turn them to 1. Okay, so this is what I get. And then to access the remaining 30% from our data set, which is our test data, if you follow the lecture, we just call IDX test, and you will get 30% of the, which is randomly selected of the data. All right, I guess that should be enough for you to, we can just jump to the machine learning part. Of course, there could be many other basic functions that you might have to learn yourself by either going to the help page or help file here, or you can just simple Google it as you need. Okay, I don't think we have time to go through everything, so I can just show you the basics, and then we should just jump to the machine learning part. Okay, I'll be using a data set called Iris. Okay, it's a very simple data set, and you can download from the website that I showed you earlier, which is the UCI Machine Learning Repository. This one. So this is the, if you just Google UCI Machine Learning data sets, maybe, I guess the first one should lead you to this page, and there are many data sets that you can play around. The one that I'm referring to now is Iris. So you can click here. It will give you some descriptions of the data set. You can go through this. Basically, there are 4 features and 1 output, which consists of 3 classes: Iris setosa, Iris versicolor, and Iris virginica. Okay. Then you can go to data folder, and then you can download the file. Right? You can try it your own. So the data file, I've already have it here. Right? So this is in this folder. So I can load this data in Matlab by using the read table function. So before that, I need to get the directory of this file, where it is located. So I can right click this, go to properties, and I can just copy this. Okay, the location, as I'll be using later. Before that, let me clear everything, clear all CLC. Okay, so data equals to read table. This read table is the Matlab function to load the data set, which is in CSV format. Okay, so this is the directory which I've just copied. But remember, the name of the file is iris.csv. Okay. There we go. This is the data set. And I can click this. So here we are. So this is our data set. Okay. So we have 5 columns. So we know from the description and our objectives that this first 4 is the features or the inputs, and the last one is our output. It consists of 3 classes. All right, that is sorted out pretty easily. Next, what do I do? Okay, let's create training data and test data using the approach that I showed earlier with our simple 11 and 12 data set. Okay, so once again, of course, you can see here, right? I have 150 rows and 5 columns. So I don't have to, but if you still want to know for sure, you can use size of data. You'll say that we have 150 rows and 5 columns. Okay. There's no real need to do that because we can see it here directly. Okay. So if you remember first IDX, you need to create the index, right? IDX train. You can call it whatever you want. Let's create zeros, which has 150 rows, right? And 1 column. So I don't want things to be displayed here. So let's suppress the output by using semicolon, or is it colon? I don't know. Okay. So as you can see here, IDX train is created. Is logical variable. We have obviously we have zeros, right? If you still want to know, double click, see it's all zeros. All right, great. Next, I want to switch 70% of the zeros to ones for the reason I explained earlier. So IDX train random sample generate. Before that, what is 70% from 150? 0.7 times 150 is 105. Okay, that's a nice number. So IDX train random sample from 150 generate 105 numbers, or in other words, generate 105 numbers between 1 and 150. Okay, access those values, which are zeros at the moment, change them to ones. So if you want to see the train, you can see from all zeros now we have many ones now. So again, if you want to know for sure how many of these ones are created, should be 105 if you remember. So I think you can just sum it, right? Sum IDX train. That means you will sum all the elements in this. So it means 1 plus 0 plus 1 plus 1 plus 1 plus 0. You should get 105. Okay, yep, that's correct. Next, let's create the index for the test data. So let's call it IDX test equals to IDX train. Whenever it's 0, turn it to 1. Okay. And if I want to know how many ones are here in my IDX test, it should be what, 45, right? Sum IDX test. Yep. So we have been doing the right thing. I think I would like to should I create my training data as test data? Okay, I think that's the way to go. Let's do that, right? Let's call it train data. Train data is from data, but remember which ones am I extracting, right? I need to use my index that we have just created. I want all the column. Okay, so in my train data, I have inputs and outputs, but the index is specified by IDX train. Okay, and then I want to create my test data. Test data, I need to use index test. All right, and as you can see in the workspace, train data, we have 105 rows. Test data, we have 45 rows as we require it. Okay, so it seems to be correct. Now we are ready, maybe, to train our model. Let's test. Let's try with decision tree first. Okay, so there's a function. I hope it's still there. It's called fit C tree. So if any information that you want to know about a function, you can type help and the name of the function, and Matlab will generate the description of the function. So it says that fit C tree equals to fit C tree returns the classification decision tree for data in the table. So this is your data and response. Why? So you should give your basically your input and output separately, right? So table contains the predictor variables, which means the features or the inputs. Y can be any of the following. You can read about this, understand things better. There are many things you can do. All right. So, but I'm just going to show the basic one. We just give the input and output, and build a tree. Okay, you can go through that if you're interested. I think you should go through as much as possible, because there are other functions that you can use to generate a better tree. Okay, let's call this model decision tree. Let's call the function, which is fit C tree. Was it? Yep. Fit C tree, right? Yes, fit C tree. I guess C is for classification. Perhaps there's another function for regression as well, using decision tree. Remember, we have to give in the first of all, it has to be training data, right? Which is 70% from data, which is in our, we have created a variable called, or a table called train data. But it has to be the inputs. So the inputs are, if you double click train data, we have 4 columns, right? 5 columns. The first 4 columns are inputs, and the last column is output. Okay, so train data, all the rows, but column 1 till 4. What is the output? All the rows, but column 5 only. Okay, I hope that's clear. Oh, that's very fast. So we have a decision tree already be trained for us. So we can actually view the decision tree. As you remember from the lecture, it should be in a, it looks like a tree. So there you go. So there's your tree, right? Too bad I cannot like move it around because, oh, okay. Okay, here we go. So it says that it starts with variable 3, and then you go to each node and then compare the features with these values given here to generate the prediction which are in the end or leaf node. Okay, so relatively very small tree because it's a simple data set. Now we are ready to compute the accuracy. Okay, in model evaluation, we compare the accuracy by using the training data itself. Okay, so but the output here is string, right? If you look at train data, let's look at the first data. It is a string. So how do we compare this? It's not a number. So there is a function in Matlab called string compare, where you can compare strings. So if I have 2 strings, let's say this and this, compare these two, it will say, okay, it is equal. If I say compare the string this and the string that, you say it's not equal. What if I have many of these strings in a table, right? This and that. So that's one table. I have another table. So the first table is this, that. Second table is that, this. So this is not equal to that, and that is not equal to this. So you should expect to get 0, 0. Oops. What's wrong here? Okay. Okay, so 0, 0. If I change to this, now this first element, oops, what is this? Continue. The first element should be equivalent to this element, that's 1. This is not equal to this, that is 0. So you should get 1, 0. Sorry, 1, 0. So I guess you understand now, right? You understand how it works. So I can use this. First, I need to predict the output from my decision tree model, which is saved as dt, and then I need to compare with the data to compute the accuracy. So first of all, let's predict first. Let me show you how to predict or to generate output from the decision tree to predict using dt. Why dt? Because I've saved my model as dt. You can call it whatever you want. Okay, let's supply the first input, which is train data, first row, but first 4 columns. Okay, should I? So it says that the prediction is Satosa. If I want to generate a prediction for the first 2 rows from the train data, it says Satosa, 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 right? But this is the output from the decision tree. We should compare this with the data set, which is in the train data 5th column. Okay, so let's predict for all the inputs in train data, right? So the output, I want to save it as maybe y. How should I call this? Y evaluation, yeah, equals to predict dt train data for all the rows, right? And the inputs are the first 4 columns. Okay, so now I have my prediction in y evaluation. Maybe I can compare. So in order to compute the accuracy, we have to compare this one and the actual data, which is in column 5, and then divide by the size. Our training data size is 105. Okay, so the way to do it is sum string compare. That means string compare will compare how many of those outputs are the same as in the data, in the training data, divide by 105, right? 105 is the number of data that I have in my training set. So here I should be using compare the output, which is y evaluation, and train data, all of those are the last column, this one. Okay, so what happens here in this inner function that I call, we are comparing the prediction and the output in the training data, which is the actual output. All right, how many of those are equal or the same? Divide by 105, which is the sample size of training data. So that will give us accuracy. Okay, 0. That's weird. Okay, cannot be 0. Let's do 1 by 1. So the way to, I mean, if any mistake that you come across, we should always like perhaps simplify the problem and try to troubleshoot. Let's compare the first one first, right? The first prediction and the first training data, 0. What is Y evaluation? Narrow down, isolate the problem. The first prediction is Arisatosa. How about the first actual output? Also Arisatosa. But how come we get 0? It should be 1 because they are the same, right? This one is the same as this. Maybe because I'm using Okay, it is a table, so we cannot use the normal parenthesis. We should use the curly bracket or parenthesis. Okay, so now it says that it is equivalent, right? The first prediction is equivalent to the first actual output. So now I can go back to the accuracy computation, change the parenthesis to curly brackets. So yeah, so our model evaluation accuracy is 98.1%. Okay, so what about my model validation accuracy? First, we need to generate the output by using this one. Okay, let's call this Y validation. Predict using my tree, but the portion of data, by using the portion of data that is not used to train it, which is test data. Again, we're going to use everything, all 45 rows and the first 4 columns. Okay, so we are ready to compute the model validation accuracy. So this should be Y validation. This should be test data, but cannot be dividing 105, right? Because my test data size is only 45. So my prediction is 97.8%, which is not too bad. All right, so that's about it for decision tree. Moving on, I'm not sure how long has passed. Sorry if this video is too long. Okay, I don't know. 37 minutes. Wow. Okay, let's make it fast. Just I'm going to show one more function, and then maybe the rest you can just find your own. How about that? All right. Let's try k nearest neighbors. Okay, KNN. So I guess the function is called something like fitc. Is it here? Fitc KNN. Yep. Okay, still here. So please go through this as much as possible. But in the most basic form, again, we just need to fill in the give in or fit in the predictors or the features and the output like we did earlier. Okay. Is that it? Yep. How about the number of neighbors? Oh, here, right? A positive integer specifying the number of nearest neighbors in X for classifying each point when predicting. Remember, in k nearest neighbor, we have to like decide how many neighbors you want to check, right, in advance. By default is 1. So if you specify only this, then by default you're only looking at one neighbor. So maybe it's not enough to generate the level of accuracy that you require. So we should provide the number of neighbors. Okay. So let's do it. Let's call the model KNN. Fit C, or maybe, you know what, we can just use the previous, you can scroll through here, right? The previous function that you use or typed. In your case, you'll be doing all this in a script, in a file, right? In my case, I'm doing it here, so I can just choose here. Okay, that's good. So I can just change this, right? dt to knn. Remember the function is fit c knn. Again, we are giving the data, the training data, the inputs, training data, and the output. By default, the number of neighbors is 1. But I want to give something else. Num neighbors, right? Let's just copy from all this. Now neighbors 5. I want to see 5 neighbors and then do the prediction as we have done it in class. Okay. Oh, that's pretty fast. So KNN is done. It's ready. Our model is here. Next, move on to prediction and then the accuracy computation. So if you remember this one, right? Where is it? Yeah, Y evaluation. Let's call this Y KNN evaluation. Predict using our model, which is KNN, using the training data. Okay, that's done. As you can see, it's here. And then we want to compute the accuracy. First of all, I'm sure there's a built-in Matlab function to compute accuracy. What I'm doing here is pretty old-fashioned, because we are comparing manually and then we are summing it manually, dividing it manually. I guess these days you can find a Matlab function. I'm sure they have created already. You just have to Google and find out. Okay, string compare Y KNN evaluation using my training data, divide 105. 96%. All right, not bad. Still lower than decision tree just now. We got 98%. So if you're not happy with 96%, you can always increase or decrease the number of neighbors, right? Let's try. So KNN, let's create another model, but I want to look at 10 neighbors instead of just 5, but 10 neighbors. Let's make it odd. Okay, 9 neighbors. Generate the output, the evaluation output, and then compute the accuracy. Again, 96%. Okay, no much change. What if I want to try 15 neighbors? 95%, it drops. Okay, so maybe we should be decreasing. I don't know, right? I'm just thinking out loud. Instead of 5, should I use 3 instead? Do I get a better accuracy, evaluation accuracy, or what? 95%? No, not necessarily. Well, there is a random element involved here, so maybe you will not always get the same answer. So I'm switching back to 5 neighbors. Output accuracy 96%. Okay. Anyway, you can try for different values. You can create a table, do whatever you want, right? This is just evaluation. I'm going to do validation now, remember? So where is it? Should be Y valley. I'm scrolling through the previous function that I used because I'm lazy to type. Yeah, here, right? Y valley. So KNN, I'm generating a new variable to store the output. Predict using KNN. Test data 1 to 4. Okay. And then compute the accuracy. Let's do a quick check. Cannon Valley test data, 5th column, 45 samples, 95%. All right, so that is K nearest neighbor. So for logistic regression, previously I used this one, MFit. What is this? MFit, oh, it's MNR fit. Okay, I made a mistake. Fit a nominal or ordinal multinomial regression model. So this is really logistic regression model. Okay, so you can go through this your own and then try it yourself how um, you can create or train your logistic regression model. Okay, it's MNR fit, not MN fit, MNR fit. Okay, I think that's all for now. The video is getting longer, already 45 minutes. So this is the video for um, training your machine learning models using Matlab. I hope in the next video, I'll try to do a video on how to train an artificial neural network using Matlab. And then the video after that should be on fuzzy logic control. All right, thank you for watching. If you have any question, please ask me face to face in the class or make an appointment and come and see me in my office. Thanks. All the best.